Hello everyone, and once again I welcome to the course on manufacturing methods. So in the previous lectures we have already discussed about what is forging process, how we can define it, what are the differences of forging with respect to rolling, or how can we compare rolling process and with respect to forging process. There we have seen that basically this forging process is a kind of localized compressive process, and as we already know it falls under for one type of forging process, forming process only. And they have seen that actually for manufacturing discrete products, so we go for this forging process. And also we have discussed about what is forgeability, what are the requirement of a particular metal to undergo forging, or whether there's a crack or not during the process of compression. Definitely those things we have discussed. Similarly, we have also discussed about differences, the different forging process of like drawing out process, cogging process. There we have seen that basically upsetting process and all. Okay, there we have seen that how to apply the, in which direction we have to apply that particular compressive force in a in the way so that we can get that required product. Okay, also we have seen how basically the shape distorts in case of forging. Okay, those things we have discussed. And we have also discussed about the manipulative ability of forging process by manipulating the fiber flow lines. Okay, so today once again we are going to discuss about some other classification of forging process, how we can discuss the different types of basic forging processes. So how we can define them? Okay, we can categorize like we can have open die forging process, that is nothing but the smith forging process that we generally see in the blacksmithes and all. Okay, so generally by using manual hammer or power hammer. Okay, we can also have impression die forging processes, like it can be closed die forging, it may be drop forging type. Okay, so there later on you'll see basically impression die means some die having a particular shape will be there on that particular, using that particular die we are going to accomplish the forging process. We can also have press forging, we may have offset forging, this can be also sometimes known as the machine forging. We can have swaging for circular cross section or taper, or making taper cross section in the product. Similarly, we can have roll forging based on the way how actually we are conducting the forging process. Here in the roll forging we will be using that means the rollers. Okay, so in this particular figure, this figure shows the different types of forging processes. So we already know this, in this forging process basically we use uh, actually some localized compressive force, and we manipulate the shape and size of that, or you can say the cross section ultimately of that particular material. Okay, and that particular product final product becomes the forged part. Okay, so now in that particular case we already know that if we the particular required compressive force is generally used by the use of different types of hammers. Okay, maybe hand tools, different hand tools, hammers, etc., power hammers, etc., etc. Okay, so now the first figure it shows the open die forging. So what will be the open die forging? So as you can see basically this dotted line it shows the original, whatever is the shape of this particular work material, from which that means we need this type of final shape. So in that particular case, what is the open die forging? Actually in the open die forging, like flat kind of dies we'll use, and we actually that hammering action we do with the help of generally this particular movable die. In most of the cases, as you can see, there are two dies, okay. So this particular die it also acts as the kind of the, it gives you the hammering action. Okay, so most of the time this particular die is fixed, and within the particular slot of die 1 and die 2 actually we have that original workpiece, and on that particular original workpiece by that we are applying force, composite force. Okay, with the help of this second die, and during that particular course of action what will happen, definitely this dotted line, this is the original shape, and it will definitely what will happen, it will get compressed. Okay, compressive force will be acting so during compression, so all of you will know. So this is the okay, so this is the opening available in between it. Okay, so lateral flow of the material also will be there. So what will be final shape that you can expect? So if initially it was something like this, so maybe after one hammering maybe it will reduce like this. Okay, maybe after this finally maybe this kind of shape will so there you can see actually in the final shape actually it is not exactly like this, but some barreling some this way lateral flow of metal it takes place, okay, in the open die forging, as you can very easily see. So this is known as the barreling action. Okay, it looks like a barrel, right? So it looks like a barrel. Okay, so this barreling action is there in the case of open die forging. Similarly, we can also have closed die forging. So as the name itself suggests, so actually the dies, both the dies, it will be like it will have some impressions on it. Okay, not kind of flat, not just flat. Okay, but you can have some impression on it, and as you can see, you can expect that during the complete, when the complete process is over, so basically both the dies, die 1 and die 2, okay, it will be kind of close. Okay, and within it, within that particular enclosure of this die 1 and die 2, we have this particular shape of this particular final part. Okay, this particular shape corresponds to the final required shape after the forging process is over. So here also you can see the dotted line, it denotes the original shape, and this is the final shape that we have here, die 1 and die 2, and you can see some extra flow of metal actually in this particular zone. Okay, so that is nothing but a flash. Okay, so what to do to like to make sure that actually completely filling of this die cavity is happening. Okay, sometimes we use some extra metal to it, and that particular flash part generally we trim off, and sometimes this in the designing itself we use the word flash. That means that is the that is the portion where the extra material will flow. Okay, so similarly we can have upsetting process, as we have already discussed. So in upsetting process, basically what happens in the upsetting process, as we have discussed previously, so if this is the material, okay, so the cross section of it increases at the expense of its length. Okay, cross section will increase but length will decrease. So that is basically nothing but a kind of upsetting process. So in that particular case, we already know if we have to accomplish this kind of compressor thing, then in which direction we have to apply the force. So along the length axis we have to apply this particular composite force. Then what will happen, this portion, okay, you can expect that some this way, like it will be it will cross sectional area will increase but length will definitely will decrease. Okay, so now this upsetting process, it can be also carried out in open setting or close option. Okay, so in the open upsetting portion, as you can already see, so two clamps, okay, or you can also consider as the die. Okay, actually not the die, this is the clamping only. So in that case we will have this particular workpiece. Okay, and you can see by the application of by the help of this ram using force in this particular direction, actually we have forced this particular head. Okay, so here you can see as we have applied the clamping here, and this face of this clamp also act as the barrier to the flow. Okay, so here you can see at this portion, actually the head of this particular bolt, you can consider another bolt that that kind of product. Okay, so those are generally force part. Okay, the head, okay, the head is basically force. Okay, as you can see the head portion, in the head portion it is cross sectional area is more, but in the side portion it is less. Okay, so similarly we can do this particular operation in the close formation. So as you can see this portion in both side, if you can see, okay, in both the sides you can see, so basically the ram is inside this particular opening, cylindrical opening, and it is acting inside it. Okay, so this is this, and this becomes the close upsetting process. Similarly we can have the swaging process, rotary swaging process. So in this particular case, okay, we have multiple rams, and basically this is the cross part on workpiece on which we are working. So in most of the cases, to reduce the particular cross section of the cylindrical bar, or sometimes to provide tapering to this particular uh, final part, we go for this swaging process, rotary swaging process, as you can see. So these are the rotary hammers. Okay, so and the final shape, this hammer face, it corresponds to the this particular, okay, here we have given some shape here, okay, so that we can work on this circular cross section workpiece, okay, or cylindrical workpiece. Similarly, we can have roll forging process, whereby actually by the application of rolls and properly manipulating the shape of this particular roll, actually we can also go for this kind of forging process, okay. So as we are using roll for giving this particular compressive force here, so also known as the roll forging process. So now how we can define different process. So in smith forging, what happens, okay, that is the very basic type. A hot workpiece is given the desired shape by the application of handheld tools and hammers, okay. So nowadays in modern smithies, okay, basically power hammers are used for the repetitive blows. So as we can see, as we have discussed with other processes also, in a single pass we have seen that generally the works are not over, okay, the product, final product, we generally don't get so similar is the case here. With the single blow of the hammer we don't get the final record shape, so we have to go for repetitive blows at repetitive locations and all. Similarly, what is drop forging? Now in the case of drop forging, the impact loads are applied to the workpiece to cause metal flow for filling up the cavity formed by the two halves of the closed dies. So we have already discussed about this, okay. So two die halves will have in between, will have the cavity which corresponds to the record shape. So in the case of drop forging, it is the impact loading, okay. Impact loads are applied to the workpiece, okay, and because of this definitely the metal will flow inside the filling up that particular cavity, okay. And now, as I have already discussed about the flash, so the excess material which is provided for ensuring the complete filling, okay, it flows circumferentially and forms a flash. And this flash, it's a kind of uh, it's actually not a part of the final product, so it has to be trimmed later, okay. So it becomes a somewhat kind of somewhat loss, okay, loss of material, but the thing is it ensures that complete filling up of cavity will be there, okay. Now what is press forging? So in case of press forging, it is gradual force which is applied instead of repetitive blows. The operation is over in a single stroke, okay. So gradually, that is the advantage of press forging. So gradually we will keep on increasing that particular force, okay, and after the whole process is over, which will take some time, okay, and the process is operation is over in a single stroke, okay. It's not like repetitive hammering, okay, but continuously the force will keep on increasing, okay. So and the final, we are going to get that particular. Next, what is swaging? So swaging, it's nothing but a special version of impact forging where the repetitive blows are obtained by a radial movement of the separate dies. So generally it is used for reducing the diameters and giving taper or tapering the bars and tubes, as we have already discussed with respect to the particular figure. Similarly, we have roll forging. Now this roll forging, it is used for reducing the diameter of rods, okay. Generally it's performed with two semicircular groove rolls held by two parallel shafts, okay. The heated workpiece is placed between the dies in an open position, okay, and after half revolution of the rolls, the workpiece is rolled out, okay, and it is then put in the smaller groove and the operation is repeated to get the final desired dimension. So that's basically what roll forging. So now here in this particular case we are going to discuss about some forging die design considerations while we'll be going for making the heads, okay, heads of bolt heads generally, okay. So now, as we already know, upsetting, it's a localized forging operation where what basically happens, the stock bar, it is compressed longitudinally, yes. So we know at the expense of its length, the increasing the cross section that we get, that is stock bar is compressed longitudinally. As we can give have a particular very important example, that is the bolt head, okay. Example of this upsetting process, use of upsetting processes, and then the forging of the head of the bolts, where we have seen that the head part, okay, it's kind of the, you can say it's a bigger compared to the shank part, okay. Now the thing say, okay, if we are talking of a particular working on a particular length stock bar, okay, and we are going for compressive force. Now there is a chance of buckling while it is undergoing compression. So now that buckling is it's a kind of failure, it leads to failure. So now we have to be sure that during the process of for this upsetting process, whenever we are talking of manufacturing the all those bolt heads and all, so it should not undergo buckling. Okay, so now if that has to happen, some rules have to be observed regarding the unsupported length which has to be forced. Okay, so now those particular design considerations are nothing but the forging die design consideration in the case of upsetting and heading process. Now what are the different design considerations that we have to consider? So by this time we have already seen it's like the process may be kind of in the closed setting upsetting, it may be open upsetting depending on how the process is being carried out. Okay, and so based on that basically we have to see what are the different condition design consideration that we have to consider. Now if it is open operation, the length of the unsupported portion which is shown here at L, it should not exceed thrice the diameter of the job. Okay, so now here we can see, so this portion, so this mass portion which is held outside of this particular support of the particular die or the clamp, whatever you say, that is nothing but the unsupported portion, or denoted by this length is denoted by L. Okay, so that if we are talking of this now similarly here is the case. Okay, this is the unsupported portion. So now if that is happening, so the length of the unsupported portion, it should not exceed thrice the diameter of this particular job. So this diameter we are talking of the initial diameter, not this particular diameter of the head. Okay, so it should not exceed thrice. Similarly, if sometimes it may so happen that depending on what is the final requirement of the size of the bolt head and all, okay, the L, that is the unsupported length, it may exceed thrice the diameter. Now if that is happening, a closed operation should be performed, but there again, once again, there will be some requirement of the die diameter and all. Okay, it should be performed with a die diameter less than equal to 1.5 times the diameter of that particular job. So as you can see in the slave figure, so the upper portion, as you can see, so the die diameter, actually it is shown by this capital D. Okay, so that particular opening, that means, okay, so this is nothing but this particular die diameter, and this portion is diameter of this particular job. Previously this much was the unsupported length. Okay, now if that happens that this particular portion, unsupported portion, it exceeds thrice the diameter of this job, then we have to go for close upsetting operation, and the die diameter should be within this particular limit. Okay, now sometimes it may so happen that it's a kind of close operation. Okay, and the unsupported length, it extends beyond the die cavity by an amount L1, as you can see. Okay, so in that particular case, whatever is the amount of unsupported length which exceeds the die cavity, it should be less than the diameter of that particular zone. Otherwise there is a failure, there is a possibility of failure due to buckling. Okay, so now these are the basic design consideration you have to consider. Now why these are important? So these are important so as to consider a proper forging process, upsetting process, whether you have to go for open upsetting, close upsetting, etc., and then only because we can get the particular type of the product that we want. Okay, so sometimes in competitive exam these are asked. Okay, maybe directly some values will be given in case of the unsupported length, or in case of suppose the diameter. Okay, and then it will be said that it is being carried out in a suppose open upsetting process, so whether it is justified or not, then you have to check whether it is within the limit of it is within the limit of 3D, that is the thrice the diameter, or not. If unsupported length is within that, then it is like it's justified that you can go for open upsetting, but if it is exceeding that, then it's not justified, you have to go for close upsetting and all. Okay, now once again similar kind of thing only. So here the three different types of forging operations. Okay, so it's being illustrated by cross-sectional sketch. So first figure, it shows the open die forging, where directly within the 2 dies, upper die and lower die, we have the workpiece, and you're applying the force. If the upper die generally the lower die is fixed, so and there is no contour and all that is given to the die, so that's a open die forging. Similarly, in the second figure, you can see the impression die forging, where some impression has been given to the two halves of the dies. Once again, lower die is stationary, upper die is moving, and upper die is giving the compressive force. And you can see the excess flow of the particular material, which is actually exceeding the required final shape. So required final shape is, that means something like this. But you have but you have got some extra part, this flash part, so this has to be trimmed off later on. Okay, this is not required. You require only this portion. Okay, so that is the flash. Similarly, we can have flashless forging, that is also important. So now in the flashless forging, you can see in this particular figure, so the die is stationary, and the punch itself will have that is the upper die. It also works like the punch, we can consider like the upper die. Okay, or you can, as it is giving the particular force, so it can also be considered as the punch, the upper die. Okay, so the punch and the die, actually both of them will be having this particular whatever is the required shape. Okay, final required shape. And you can see during the course of this particular uh, this particular this one setting. Okay, as you can see, as this way also lateral movement of this particular um, it's prevented. So basically it will be, there will not be any flash there. Okay, generation of any flash. And so whatever is the required whatever is the initial workpiece, okay, on that initial workpiece we are going to work, and we are going to get the final workpiece like this, and there is no requirement of any cutting of the or trimming of the flash and all. Okay, so this is a flashless process. So that is also possible by, but in that particular case you have to take extra care during the proper designing of the both the dies. Okay, similarly in this particular figure you can actually see whatever we have previously discussed. That means during the course of action of open die, actually we get a barreling action. So you can see there are three successive figures actually that is being shown. So the figure shows the actual deformation of a cylindrical work part in an open die forging, and you can see very easily the barreling action. So this figure shows the initial start of the process. So when we have the workpiece here, both the dies are here. Okay, and this particular shows a partial deformation. It is undergoing some deformation. Length, you can see the decrease in height. Okay, but increase in the diameter. Okay, so the knot and the both are different, and actually it is showing the final shape. So in the final shape, you can very easily see this barreling. Okay, barreling is there. It is not, the final shape is not something like this, but it has got some, actually it is undergoing some barreling action. Okay, lateral movement will be there. Okay, similarly this particular figure shows the different sequence in impression die forging. So the first figure shows it is the just prior to the initial contact with the raw material. Okay, we already have the shapes given to this particular dies. Okay, so that means this particular portion should get filled up, should be filled up after the process is over, and that is going to give us the shape. And second figure, it shows partial deformation, partial compression. Okay, so it has somewhat like it is undergoing deformation, and length has been or I consider height is decreased, and it is laterally flowing. Okay, and in the final one, it's the final die closure, and it shows the flash formation in the gap between the die plates. So basically what is happening, as we have provided some extra material, okay, initial stock material, so it's the extra material that we provide, and because of that what happens, it we can be sure that actually it will flow through all those nooks and corners which are unfilled. Otherwise, if we provide just enough material, okay, then sometimes it may so happen that somewhere there may be some little flow and all, some gaps, etc. It may not fill up properly, but if we apply the extra material that has given, it ensures that basically it will fill up completely the whatever is the possible cavity that is there, or wherever possibly the material can flow, and after that laterally through this particular opening also the extra material will come up. That is nothing but the flash. So here we are showing some flashless forging as we have already discussed. So first figure shows the initial starting. So it's in this particular case, that means the proper volume of the initial stock you have to calculate and properly you have to take as per the requirement of the final finished parts. So in this particular case there is no extra trimming and all that is necessary. So second figure shows that no, the barreling action and somewhat compressed, and third figure it shows the finished part where actually due to the whatever is the shape of this particular die and punch itself, okay, actually there is no possibility of formation of any flash. Okay, now in this particular figure we are discussing some open die forging and some related operation. So there are some other open die forging operation where what we use, okay, and it's like the here we are discussing the fullering, then edging and cogging. So what is this fullering? So basically fullering is a forging operation which is performed to reduce the cross section and redistribute the metal in a work part in preparation for subsequent shape forging. Basically it's accomplished by dies with convex surface. So that is important. Fullering is a convex surface dies we have. Okay, so this is shown the first figure. So you can see the die. Okay, fullering die cavities are often designed into multi-cavity impression die so that the starting bar can be rough formed before the final shaping. So that is basically about fullering. Okay, and you go through some other expressions that is there with respect to fullering, like fullering impression. Okay, similarly with the help of edging, basically you go for like edging impression and all. What is this with respect to this die design? Okay, that's your task. Okay, it's the assignment. Similarly, what is edging? Edging is similar to somewhat similar to fullering, but here the basic difference is the dies have convex shape. So you can see the face now is different. Okay, now it is concave. Now what is cogging operation? It consists of a sequence of forging compressions along the length of a workpiece to reduce the cross section and increase length. So already we have discussed about drawing out and cogging operation. So in the cogging operation what happens, and perpendicular to the length axis we have to apply the force, and during that particular course the length will increase, the cross section will decrease. Those things we have already discussed. So here it is being shown. Similarly we can have drawing out operation, okay, where the consider reduce here the cross section will reduce, drawing out or cogging. Okay, and already we have discussed about the upsetting. Okay, so just like the case of with the case of any particular type of process, so forging also may have some defects. So in the case of forging, okay, so the defects are known as the forging defects, just like in the case of casting also we have seen some defects and all. Okay, so here also some defects like unfilled section, where basically there will not be filling of the some die cavity. Similarly we can have different cold shot, pitting, okay, scalping. Sometimes the die may shift, that is known as die shift. You may have some flakes that is on the surface of the particular work part, final part. Okay, similarly grain flow, whatever direction we want it, may be due to the hammering action and all, it proper grain flow it is not happening. So these are some of the forging defects. So this is for your self study. Okay, you go through them in details, what are the causes, okay, remedies, etc. Okay, so that's your. Similarly, whenever we're talking of this going for forging process, so we already know that mostly it's some impression that we give to the dies, okay, and that means the die for this particular forging process has to be properly considered, the die design has to be proper. Okay, so some in that particular case, once again some of the important parameters are there, some of the important considerations are there with respect to forging die design. So what are some of the important die design considerations I am showing here? So I want that all of you will be going through them in details uh, from many books and all. So here what is being shown, so uh, like we can see this particular figure. So in this figure different terminologies for a conventional impression die forging that is being shown. Okay, so now here we are showing the parting line. So this is the parting line, just like in the case of casting and all, the two have specific parts. Okay, so we can have we sometimes provide the different draft. It may be inside draft, maybe the outside draft to the particular, so that proper taking out of this proper final part after the process is over, it's becomes somewhat easier. We also provide some radius to the fillet and the corner radius that we provide. Okay, so that is for like strength consideration or flow of material consideration. And we also provide shrinkage allowances. Okay, we already know if we are talking of forging, basically it's a these are hot forging operations. Okay, so we heat the metal. Okay, then we, when it is heated, we like just like you might have heard a proverb, heat the metal when it is heat it when it is heated. Okay, so in that particular case, like we actually taking care of the flowability of the material, increased ductility in case of elevated temperature. So that we already know. And if we are talking of like working with a heated metal, then when it will be undergoing cooling, so we know that some shrinkage etc will be there. So now we also apply for, like during the design consideration of the these dies. Okay, we also have to go for shrinkage allowance. So it is to account for the shrinkage of the hot workpiece during the cooling process. Similarly, we also provide die wear allowance. So this allowance, it is to account for the gradual wear of the die which its use. So you already know whenever we are talking of using die, so this die, it's not a single use. Okay, die and punch. Okay, basically it will be multi passes, multi use type of thing. Okay, and we already know it will be in contact with the heated metal, as well as it's actually giving the all those for compressive force and all. So gradual wear and all, it will be there. So some die wear allowance also we provide. Similarly, for post processing operations, so as we know, once just after the product is manufactured by the forging process, it may not be suitable, or the aesthetic looks or the finishing etc may not be proper. Okay, so in those cases, some finishing allowances for post processing we also provide. Similarly, you have to take care of all those different ribs, like rib or wave or all those particular cavities etc. Okay, so those are some of the die design considerations. So now proper die design, mainly with respect to the impression dies and closed dies, is very important in the for the success of a forging operation. Okay, so the parts to be forged, it must be designed based on the knowledge of the principles and limitations of this process. Okay, because we already know, like some of the things, suppose if some process is unable to provide a particular required part and all. Okay, whatever the limitation, what is the process capability and limitation, those things we must know. Okay, so now we are discussing about this. So the process. So similarly, about parting line, you already know it's nothing but the parting line. It's a plane that divides the upper die from the lower die. Okay, and sometimes also it is known as the flash line in case of impression die forging. Okay, so basically here this is the plane where the two halves of the die is matched, and the selection by the designer, it actually affects the proper grain flow in the part, required load and flash formation etc. So that's why selection of proper parting line is very important. It can mostly symmetrical, if you can have symmetrical impression and all, depending on like you can say the product. Okay, definitely it will depend on the look of the product. Okay, shape and all. So parting line consideration is very important. Okay, similarly draft, what is draft? It's nothing but the amount of taper on the sides of the part which is required to remove it from the die. Okay, the actually this term also applies to the taper on the sides of the die cavity. So that is nothing but a draft. We have already seen it's a kind of tapering. Okay, and generally draft angle is like 3 degree on aluminum and magnesium parts, and 5 to 7 degree on steel parts. Okay, so steel parts we generally give more draft allowance, so that taking it out from the die cavity, it becomes somewhat easy. And if we are talking of the very precision forging, then this draft angles are near zero. We provide some draft, but as we are talking of precision forging process, so it's somewhat zero. And now about waves and ribs. So what is this wave? It's nothing but a thin portion of the forging that is parallel to the parting line. So that part is known as a parallel part, is known as the wave. Okay, and rib is once again the thin portion that is perpendicular to the parting line. Okay, so actually these part features actually some causes sometimes difficulty in metal flow as they become very thin. So this how many waves or what or waves, ribs etc is there will be there in the final part. that has to be properly considered, and proper like flowability, that is forceability of the particular material also you have to consider and all. Okay, similarly fillet and corner radius, okay, these are required to provide streamlined path for flow of the metal. So if we provide this the radii, okay, then flow of the metal in this particular section becomes, it is not generally hampered. It is hampered if it is kind of very corner that we have, okay, there is no radius. Okay, so small radii tend to limit the metal flow and increase stresses on die surfaces during the forging. Okay, next, what is about flash? So this technically we have already seen, this is nothing but the extra material. Okay, this flash formation, it plays a critical role in the impression die forging by causing pressure to build up inside the die so as to promote the filling of the cavity. Okay, this pressure buildup is controlled by the designing a flash length and a gutter into the die. So how much we can say pressure it has to build up so as to properly fill up that particular die cavity can be controlled by giving flash lane and gutter in the die. Okay, so the lane determines the surface area along which lateral flow of the metal occurs, thereby controlling the pressure increase inside that particular die. And this gutter, it permits the excess metal to escape without causing the forging load to reach its extreme value. Okay, so both of them are important. So here in this particular chart, we have just shown some compatibility charts for materials and processes. And as you can see, so definitely selection of a material, it may restrict the possible processing process. So here it is not only about this cast like forging only. So we are discussing with respect to say for different processing process. Okay, and sometimes we can see the selection of a process, it may restrict possible materials. That means if we are talking of, suppose we have to go for a particular process, then all the materials we may not be able to process by this particular process. Similarly, if we talking of making a building a part with a particular material, then all the processes may not be suitable for this. So this search gives you an indication whether you can go for a particular form a particular product by a particular process or not. Okay, so this is about this particular lecture. Okay, so definitely it's not the complete content for this module, so all the other portions you have to consider. Okay, so thank you everyone.